Nuclear physics, lecture 3 beta. Yesterday, what we have done? Binding energy per nucleon,
Yes, sir.
isn't it? Now tell me, binding energy per nucleon is highest for which number beta I told you? This is your binding energy curve. Very important curve beta, you need to remember. On y-axis, what you are taking? Binding energy per nucleon. Binding energy per nucleon. What will be the unit in terms of your mega electron volt on y-axis? On an x-axis, we are taking mass number. We are taking what? Mass number. That is nothing but equal to your A. Okay. I told you the graph is something like this. It will be your like this right now for me, maximum, then it will be decreasing. Okay. Maximum for which element I told you, beta?
Iron, sir.
Iron. Very good. Iron is having the highest binding energy per nucleon. Okay. So iron is right now for me Fe 56 mass number. Okay. So mass number is right now for me here 56. Okay. And we are starting from which element? Hydrogen like element. Like say first one is like 1H1, then the 1H2. Like that, all the elements, lithium, nitrogen, go on like that. If I specifically draw the diagram also better, it is up to helium right now for here. Then it will be decreasing for your lithium. Then again, it will be increasing for your carbon. Then again, nitrogen. Then again for your oxygen. Then again for your sulfur. Go on like that one, basic elements. Okay. This will be for your lithium here right now decreasing. And here it is right now for your helium. Okay. Like that, the graphs will be there. Okay, beta. So what are the points you need to remember in this one? Binding energy curve is maximum for your iron. Binding energy per nucleon is maximum for what? Iron. Whose mass number is how much for me? 56. And how much is the value of this one, beta? And its value is 8.75 MeV. You need to remember what is the binding energy per nucleon for iron. What is the answer for that one? 8.7 MeV, which is your highest. Am I clear?
Yes, sir.
Sure. Yesterday we also done your Q values, na beta?
Yes, sir.
Q value we have been completed, isn't it?
No, sir.
Sure. Clear. All the lighter elements like hydrogen, helium, lithium, they undergo a process called as what for me? Fusion. And all the heavier elements will undergo a process called as what for me? Fission. That means heavier elements will try to break and attain the stability of your iron. Lighter elements will get add up to attain the stability of your iron. Okay.
Yes, sir.
So what do you mean by this one? That means that lighter nuclei undergoes a process called as what? Fusion. In the fusion, energy is released. These are very important points for your examinations. Okay. And all the heavier elements and all the heavier nuclei, they'll break, and the process of breaking is called as what? Fission. In the fission, energy is released. Am I clear? In both the process, what is happening? energy will be released. Energy is released. Okay. Heavier nuclei means breaking. The process of your breaking of heavier nuclei is called as what? Fission. Lighter medium means adding. Addition of lighter nuclei to form a heavier element is called as for me what? Fusion. Okay. Am I clear?
Yes, sir. Yes, sir.
So that means
Yes, sir.
in any nuclear reaction or process, energy will be what will be the energy, beta? Will it be released or absorbed? Energy will be released. This point you need to remember. Am I clear?
Yes, sir.
Sure. So what elements undergoes the fusion, beta? Fusion is undergone by your lighter nuclei. Lighter nuclei means adding, whose mass numbers are right now lesser than 30. And whereas, what do you mean by heavier nuclei? Heavier nuclei is undergoing right now for me what? Breaking. So breaking down of the heavier nuclei to form the lighter nuclei is called as what? Fission. In this one also, energy is released. And even in the fusion, energy is being released. Am I clear?
Yes, sir. Yes, sir.
Next one, and very important point, radioactivity. Radioactivity. What do you mean by radioactivity, beta? It is a nuclear phenomena in which an unstable nucleus undergoes a decay to attain the stability. That is called as of your radioactivity. So I can say this one is what is nuclear phenomenon in which your unstable nucleus undergoes a decay to become stable nuclei is called what? Radioactivity is called radioactivity. Am I clear? What do you mean by radioactivity now? Radioactivity is nothing but what? A nuclear phenomena in which your unstable nucleus is undergoing a decay to become what? A stable nucleus. This phenomenon is called as right now for me what? Radioactivity. In our syllabus, we are having three radioactivity phenomena. First one is known as of your alpha decay. And next one is known as right now for me beta decay. And third one is known as of your gamma decay. Okay. So first one is right now for me what? Alpha decay. And next one is known as what for me? Beta decay. And third one is known as what for me? Or gamma decay. Gamma decay. And beta decay, we are having two processes beta still in our syllabus. One is known as of your beta minus decay. And another one is known as of your beta plus decay. Beta plus decay. That is represented here by beta minus, and this is represented by beta plus. These are the three nuclear phenomena which you need to remember for your NEET exams. What are the three decays? Alpha decay, beta decay, gamma decay. Let me firstly revise you. What do you mean by your alpha decay? See, in alpha decay, what is happening is a parent nuclei. Remember the reaction like this: X, Z, A. X is a nucleate beta. It undergoes to form a daughter nucleus Y, whose atomic number decreases by 2, Z minus 2, and mass number decreases by 4, A minus 4. And along with that one, we get an helium particle, 2He4. Okay. This 2He4 is known as what for me, beta? This 2He4 is known as of your alpha particle. This is known as what for me? This is known as of your alpha particle, which is called as what? Nucleus of helium. This is your nucleus of your helium. Okay, and alpha particle has what? It has two protons and two neutrons. Am I clear? 2He4. Am I clear?
Yes.
Sure. So in alpha decay, what is happening? A parent nuclei. This is known as of your parent nuclei. And this is known as what for me? Daughter nuclei. So what is happening in this one? Can you tell me once? Atomic number is decreasing by 2, Z minus 2. Mass number is decreasing by A minus 4. That is known as of your alpha decay. Am I clear? Sure. The next one is beta decay. Next one is your beta decay. In beta decay, what is happening is the nuclei X, Z, A, it is giving you Y. In this one, atomic number increases by 1 and mass number remains for me the same. Plus, we get a beta particle, that is beta naught minus 1, and an anti-neutrino represented by nu bar. This nu bar is known as what for me? This one is called as of your anti-neutrino. Clear? Am I clear?
Yes, sir.
See, in this one, what is happening is, example, if I take you, if there is a neutron, this neutron will get converted into your proton plus one electron and one anti-neutrino. Okay? Am I clear? And even in
Yes,
this
sir.
one, N by P ratio decreases. In beta decay, N by P ratio decreases. Why? Number of neutrons will be decreasing and number of protons will be increasing. So obviously the ratio will be decreasing. Am I clear?
Sir, I didn't understand.
Now in this one, see number of neutrons, what is happening? See, neutron is getting forming into your proton, no? So number of neutrons are decreasing and proton value is increasing. Like see Z, this is Z and this is Z plus 1. It is increasing now. Z is nothing.
Yes, sir.
Number of protons. Number of protons are increasing. And here the number of neutrons are decreasing. A minus Z. Okay, like say in this one, number of your neutrons will be equal to, like say if I'm having N minus of your 1, beta minus. Whereas number of protons is right now for me P plus 1, because Z plus 1, it is increasing. Isn't it? So in beta decay, what is happening to the atomic number? Atomic number is increasing, mass number is remaining for me same. This is A, this is also your A. But what is happening to atomic number? Atomic number is been increasing by your 1. Am I clear?
Yes.
Isn't it? Now in this one, neutron is being converting into what? Proton. In beta minus decay. This is right now for me what? Beta minus decay, you can write in the bracket. Beta minus decay. In beta minus decay, atomic number will be increasing by 1 and mass number will be remaining for the same. What is the N by P ratio? N by P ratio will be decreasing. So neutron is getting converted into proton. In this one, N is right now for me what? Neutron. Neutron is getting converted into, neutron converts into what beta? Proton. Neutron converts into your proton. Okay, let me give an example for you. Like say I'm having phosphorus. Atomic number is 15 and mass number is 32. It will give you, if it is undergoing a beta minus decay, it will give me what? 16th element. 16th element is sulfur. Mass number will be same. Along with that one, an electron is liberated and an anti-neutrino is liberated. This will be the reaction. Am I clear? So in beta
Yes, sir.
decay, if someone asks you what is a beta minus decay, Beta minus decay is nothing but a process in which atomic number is being increasing by 1 and mass number is remaining for me the same. N by P ratio will be decreasing. So the process of converting a neutron into your proton is called as of your beta minus decay. Am I clear? Am I clear?
Yes, sir.
Next one is beta plus decay. Beta plus decay. This one is beta plus decay. Okay. In beta plus decay, N by P ratio is lesser than 1. Okay. What is the N by P ratio? Lesser than 1. That means N by P ratio is increasing. N by P ratio increases. Why? Proton is decreasing in this one. Okay. So proton is decreasing and whereas neutron is increasing. Isn't it? If proton is decreasing, what is happening to the ratio? Obviously, it will be increasing. So how do you write the beta plus decay reaction better? Like say in this one, if I'm writing the element, if this is your XZA, okay. So if I'm writing the element right now here, it is your XZA, XZA. Okay. It is giving me a daughter nuclei. In this one, what is happening? See better. The element XZA undergoes a reaction. If it is undergoing a nuclear reaction, such that it is undergoing beta plus decay. In beta plus decay, it is giving me a daughter nuclei Y whose atomic number is decreased by 1. So number of protons are decreasing. Mass number will be remaining for me the same. This will be equal to your A. Okay. And along with that one, we get beta plus and we get a neutrino. Nu is known as what for mu? Neutrino. Neutrino. Okay. So here what is happening? Z value is being decreasing by 1 and mass number is right now remaining for me the same. For what pass of decay? Beta plus decay. And along with that one, what is liberated beta? A neutrino is being liberated. Am I clear? That means in this one, proton is getting converted into a neutron plus an electron, positive positron plus of your neutrino. E plus means right now for me what beta? Positron only, no? Isn't it? E negative means electron. E plus is nothing but me positron. So proton is getting converted into your neutron, positron and a neutrino. So the process in which what is happening? Proton converts into neutron is known as the pure beta plus decay. And along with that one, we are getting a proton and nu bar is known as what for me? Neutrino. Okay. And N is right now for me what? Neutron. And P is your proton. So proton is getting converted into a neutron plus a positron and a neutrino. Am I clear? Let me give
Yes,
an
sir.
example. Like say sodium 11, mass number is 22. Tell me what element I'll be getting here. 11 minus 1. That means the 10th element. What is the 10th element? Neon. Mass number will be still 22 plus 1 positron plus your neutron. Am I clear? Am I clear?
Yes, sir.
Sure. The next one is your gamma decay. Next one is about your gamma decay. This is your symbol. This is your gamma decay. See, in gamma decay, beta, nucleus from an excited state comes to your ground state. That is the only thing you need to remember. So, excited state nucleus will come to your ground state. Nucleus from excited state comes to your ground state. Comes to your ground state. Am I clear? That means if I write in nuclear reaction X, Z, A, okay, and keeping a star mark here. Star mark represents your, it is in your excited state. Excited state. By undergoing a process called as of your gamma decay, it will get converted into your again X, Z, A. There is no change in atomic number, no change in mass number, plus certain energy in the form of gamma radiations. Am I clear? So what is happening in gamma decay, beta? There is no change in atomic number and there is no change in mass number. It will remain for me the same. It will just come from your excited state to your what state? Ground state. So that process is called as right now for me gamma decay. Am I clear? Once again. So in radioactive beta, alpha decay, atomic number decreases by 2, mass number decreases by 4. Beta minus, atomic number increases by 1, mass number remains same. Beta plus, atomic number decreases by 1, mass number remains same. In gamma decay, there is no change in atomic number, no change in mass number. Am I clear?
Yes, sir.
Sure.
Yes, sir.
Let me give an example. So let's try to give me the answer for this one. I'm having an element X whose atomic number is 100 and whose mass number is 212. And the problem is telling that it is undergoing an alpha decay and beta decay. Both of them are undergoing. What is the resultant nuclei? Daughter nuclei will be equal to how much? Can you tell me? 1 alpha means what, beta? You tell me. 1 alpha means Z value decreases by how much? 2. And A value decreases by
Sir.
how much? 4. Am I clear?
Yes, sir.
Now tell me. Now see, if in the problem he has given me that, I'm getting here right now 90 and here is right now for me 180. That is given in the problem. Now the question is asking is find number of alpha and beta particles decay. How many of them are decayed? So that I'll be getting from 100 to 90. That means how many alpha should be decayed? 1 alpha, 2 alpha, 3 alpha. You know that if 1 alpha is been decaying, atomic number decreases by 2 and mass number decreases by 4. Am I clear?
Yes, sir.
Now tell me. Now see if I'm talking about for alpha particle better. First I'll talk about alpha particle. Change in mass number divided by 4. Change in mass number is how much better? We are getting 212 minus 180. I'm getting there 180 divided by 4. So 212 minus 180 is how much? 32. 32 divided by 4. That will be equal to how much for me? 4 8s are. That means 8 alpha particle it should undergo. It should be undergoing how many decays beta? 8 alpha particles decay. Am I clear? That means X element 100 to 12. If it is undergoing 8 alpha decay. It is getting right now for me some element, like say for example D, whose mass number decreases by your how much beta? 180. Okay, and atomic number is being decreases by how much beta? 100 minus 90. Tell me how much it will be beta? 8
10.
alpha particles. 8 alpha particles means 100 minus 16. Then 100 minus 16. 8 alpha particles means 1 alpha particle is 2. So 8 alpha particles means how much? But 1 alpha particle is
Yes.
undergoing 2, the atomic number decreases by 2. If it is 8 alpha particle, that means Z value decreases by how much beta? 16, na? 100 minus 16 is how much for me? 84. Am I clear?
Yes, sir.
Now, this D element should go on process so that I'll get Y, whose atomic number will be 90 and whose mass number will be same. So mass number is same, but atomic number is being 84 to 90. Will it be beta minus or beta plus? Z value is increasing. 84 is here and
Beta plus.
90. How much I add so that I'll be getting 90 here?
6.
6. That means 6 beta plus or beta minus?
Plus. Beta plus, sir.
Huh?
Beta plus.
Beta plus. See? If it is beta plus, Z value is decreasing by 1. If it is beta minus, Z value is increasing by 1. So it should be
Beta minus, sir.
beta plus. Plus or minus beta?
Minus, sir.
Minus, na? Beta minus. Am I clear?
Yes, sir.
It should be your beta minus, 6 beta minus. So what is the answer for this question? How many number of alpha particles beta? 8 alpha particles and 6 beta particles will be the answer. Go through it once again. If there is any doubt in this question, please let me know. If I did this question, you just go through it. Given question is X element whose atomic number is 100 and mass number is 212 and it is undergoing some process of alpha and beta decay so that it is giving me atomic number 90 and mass number 180. It is asking find me the number of alpha particles and beta particles decay. How I am doing right now for me beta? Write the change in mass number divided by 4. So here it is 212 and opposite is 180. So 212 minus 180 divided by 4. So 32 divided by 4. So it is how many alpha particles? 8 alpha particles. So if it is 8 alpha particles means atomic number decreases by 16 and mass number decreases by your 212, 32. Isn't it? That is 8 alpha particles will give me 180. Then from there we need to get Y element whose atomic number is 180 and mass number is atomic number is 90 and mass number is 180. So that means 180 to 90 means it will be beta minus because Z plus 1. So it is 6 beta particles and mass number remains for same. So the answer should be 8 alpha particle and 6 beta particles. Am I clear? Any doubt in this one?
No, sir.
Now think and give me the answer for this question. This is your X. Here it is 98. Here it is 98. And mass number is 204. Okay. It is giving you A. It is giving me B. It is giving me C. And C is giving me your D. And D is giving me your E. Now here it is A, here it is your B, here it is C, this is D, this is E, this is F, this is G, this is H, and this is your I, and this is your J. My question is, find the values of A, B, C, and E. Find the values of A, B, C, D, E, F, G, H, I, and J. Okay. If it is undergoing a process here, one alpha particle, one beta minus, then again it is undergoing an alpha particle, then here it is undergoing beta plus here, then here it is undergoing the gamma decay. Now tell me the answers for this one. If X is undergoing an alpha decay, what is your A and what is your B? Think and give me the answer. Alpha decay means mass number decreases by how much? Huh?
2.
4. That means 204 minus 4. That means here it will be equal to how much? 200.
Mm-hmm.
And atomic number decreases by how much? 2. 98 minus 2 will be equal to 96. Am I clear?
Yes, sir.
Minus. There is no change in mass number. So C will be equal to how much for me? Same now.
C is 200.
C will be equal to how much?
200.
What will be the D? Beta minus. Atomic number will increase by
97. 97.
97. Very good. Then again alpha decay. That means mass number will decrease by 4. 200
4.
minus 4. E will be equal to how much?
196. 6.
Very good. It will be 96. Am I clear? E value will be equal to 196. 196. What is F value? 97 minus 2.
95.
95. Then beta plus decay. When beta plus decay is undergoing, mass number will be same. 196. What is happening to atomic number?
Decreases.
Decreases by how much? 1. 95 minus 1. It will be 94. Then 94, if it is undergoing the gamma decay, if it is undergoing the gamma decay, there is no change in mass number, no change in atomic number. That means I value will be equal to 196 and J value will be equal to 94.
94.
Am I clear?
Yes.
Any doubt in this one?
Yes, sir. No, sir.
Clear?
Yes, sir.
Sure. Give me the answer for this question method. In the nuclear decay given below, that is X, Z, A undergoes you Y, Z plus 1. And here it is right now for me A. Again, it is giving me your B, some excited state. This is your Z minus 1 and mass number is A minus 4. This will give me the B. This is your Z minus 1 and it is your A minus 4. The question is, the particles emitted in the sequence are First option is alpha, beta, gamma. Second one is beta, alpha, gamma. And third one is gamma, beta, alpha. And fourth one is beta, gamma, alpha. क्या हुआ? चलो ट्राई करो बेटा. The nuclear decay given below. X gives you Y, Y gives you B. B is an excited state, then B again will give me B. No change in mass number, no change in atomic number. So obviously that process will be equal to what?
Gamma.
Gamma. So that means in the last 110%, you will be getting what? Gamma. That means the third option and fourth option will not be there. Pakka.
So second option.
Is alpha. So what will be the correct sequence?
Second option.
Second option. Very good. Because Z is increasing by 1. If it is Z is increasing by 1 means what should be here? It should be your
Beta.
beta minus decay. Isn't it?
Yes, sir.
Then
Yes, sir.
Z plus 1, Z minus 1. And A mass number is decreasing by 4. So obviously it should be what? Alpha particle.
Alpha.
Am I clear?
Yes.
See, Z plus 1 minus 2 will be equal to how much for me? Z minus 1 only, na? So the answer will be equal to beta, alpha, and gamma. Am I clear? Any doubt?
Yes, sir. No, sir.
See this question. A nucleus of XZA emits 9 alpha particles and 5 beta particles. The ratio of total protons and neutrons in the final nucleus is a nucleus of XZA emits 9 alpha particles. Write the reaction. XZA. What is the reaction right now here? XZA. XZA. It undergoing how many? 9 alpha particle. So we are getting X. So atomic number will decrease by 18, mass number will decrease by 36. So Z minus 18, A minus 36. 5 beta particles, that means Z minus 13 and A minus 36. There is no change in the mass number. So what will be the number of protons, beta? Number of protons will be equal to how much for me? Z minus 13 for X. Isn't it? And what is the number of neutrons for your X? What do you calculate the number of neutrons, beta? Atomic number minus neutron, A minus Z. So it is A minus 36 minus of your number of protons.
23 minus 20.
So it is A minus Z minus 23. So it's asking P by N. So P by N is how much only? Z minus 13 divided by A minus Z minus 23. Am I clear?
Yes, sir.
What was asking the problem? The ratio of total protons and neutrons in final nucleus is asking. In final nucleus means X only, na? In X, what are the number of protons? Number of your protons means atomic number only, na? Z minus 13 is your number of your protons. Now, how do you calculate the number of neutrons? A minus Z. A is how much for me? A minus 36 minus Z. Z is right now Z minus 13. If I open the bracket and simplify it, you will be getting A minus Z minus 23. It is asking the ratio of what? P divided by N. So just take the ratio. This one divided by this one. So that will be the answer. Am I clear? Any doubt in this question, you see? Alina, देख लो बेटा.
जी सर.
Again. Read the question carefully. Everything is given in the problem. A nucleus of XZA emits 9 alpha particles and 5 beta particles. The ratio of total protons and neutrons in final nucleus is asking. First, you see that if it is undergoing 9 alpha particles, atomic number will decrease by 9 to the 18. And I told you how to calculate the mass numbers. It is A minus of your alpha particles will be equal to 36 for 9 the, isn't it? So it is A minus 36 divided by Z minus 18. Then 5 beta particles, mass number will be the same. Atomic number will be decreasing by 1. So it is Z minus 30. 5 times. So number of protons in the final nucleus is Z minus 13 and number of neutrons is A minus Z minus 23. So take the ratio of that one, that will give me the answer. Am I clear?
Yes, sir.
See this question. When a uranium isotope of 92 uranium 235 bombarded with a neutron, it generates lepton, 3 neutrons, and what will be the reaction? Write the reaction. Uranium 92 plus 235 is bombarded with a neutron. That means I'm adding a neutron here right now. So when I add a neutron, so what is happening? Mass number conservation. So we are getting right now in the problem krypton, and we are getting 3 neutrons, and we are getting some X. What is this X? A and B. What is the total mass number, beta? On left hand side, 330, 235 plus 1. So it is 236. Mass should be conserved. So here it is 89. And here it is 1. 89 plus 1, it is 90. And here how many? 3. So it is 89 plus 3 plus A must be equal to 236. So A value is how much? 144. So you should element in barium 144, 56. Clear? We just equate the masses on the left hand side and right hand side. That will give me the answer for. Just go through the question once again. When a uranium isotope,
Yes, sir.
uranium 235 is being bombarded with a neutron, it generates a krypton and 3 neutrons. Is asking which option will be best matching there. So at first I taken the reaction. 92 uranium 235 is reacting with one neutron. So mass number will be equal to how much for me? 235 plus 1, 236 on left hand side. It is giving you what? Krypton 36 and 89 and 3 neutrons plus some element X. Okay, we need to calculate that X element. So first I equated the masses on left hand side and right hand side. 236 must be equal to 89 plus 3 neutrons covered 3 plus A. That will be equal to, must be equal to how much for me? 236 here. So if I equate both of them, we are getting a mass number A is equal to how much for me? 144. So in 144, which option has been available? But first option. So that will be the answer for that. Am I clear?
Yes, sir.
Even this question you see. A nucleus X, whose atomic number is represented by N and mass number represented by small m, emits 1 alpha particle and 2 beta minus particles. The resulting nucleus is how much? See the reaction, see if you are able to understand that one or not. X, Nm undergoes an alpha decay. If it is undergoing an alpha decay, atomic number decreases by 2, mass number decreases by 4. And 2 beta minus decay. In beta minus decay, neutron is getting converted to proton now. Isn't it? So n minus 2 will become for me n. Mass number will remain for me same, m minus 4. So it should be answer for me what? It should be an X element with n, m minus 4. Which option will be matching to? The resulting nucleus is atomic number is atomic number is n and mass number is m minus 4. Which option you are able to connect that one? Option number 3. Isn't it?
Yes.
Now see this question. Complete the equation for the following fission process. Fission means what? A heavier nucleus has been disintegrating into lighter nuclei. 92 uranium 235, where it is reacted with a neutron. We get a SR 38 and 90 strontium. Now consider the mass numbers on LHS and RHS. 235 plus 1, it should be 236. There it is 90. 90 plus something must be equal to that much. So it is 236, 90 plus 146. 146 means along with that one 3 neutrons. So here 3 and here 143. 143 plus 3 neutrons. It will be 146. That means first option will be the one which will be giving me the answer for that one. It should be eliminating, it should be emitting 3 neutrons and an element X whose atomic number is 54 and mass number is 143. Clear? I hope I'm clear with this one till this point, beta. Nuclear forces, and tomorrow's session of a class we'll try to do the problems related to your power concept. Okay. Tomorrow is 15th August. If you are free, we can take a little bit longer. Later, if you want to take leave, then we'll try to decide the class on Saturday if it is possible. Okay, but class will be as usually. If it is possible, you try to join it.
Okay.
Okay, na?
Yes.
You please go through the notes. I'm also sending the YouTube, what you call that one, video lectures of uploaded for you. You just go through them and try to start doing the PYQs of the nuclear physics. Easy topic, you'll be getting 4 marks directly better. 4 mark questions for your NEET, you should get compulsorily 4 marks. One more small topic.
Yes.
That one, that is about your nuclear power. Once we are done with that one, then we'll try to do the problems on your nuclear physics. So we'll keep a full stop for this one as early as possible with the PYQs solving. Am I clear?
Yes.
Okay.
Yes.
Good. Bye.